Introduction to Generative AI. Basic Concepts and Techniques. By Engineer Ebrahim Hamed Shalabi. Generative AI is a revolutionary branch of artificial intelligence, characterized by its ability not only to analyze existing data, but also to generate entirely new and original content, such as text, images, music, code, and even video. This field relies heavily on deep learning techniques, a branch of machine learning that uses deep artificial neural networks, ANNs, inspired by the structure of the human brain, to process massive amounts of data and discover complex patterns. Basic models and architectures. 1. Transformers. Transformers are the cornerstone of many modern generative models, particularly in natural language processing. This architecture features a self-attention mechanism that allows the model to weigh the importance of different words in context, enabling it to better understand long-term dependencies. Compared to previous architectures such as recurrent neural networks, RNNs, which process data sequentially, transformers operate in parallel, which speeds up the training process. 2. Large language models. LLMs. These are AI models often built on the transformer architecture, trained on massive amounts of text data. Big data. Some of the most well-known examples are OpenAI's GPT, generative pre-trained transformer model family, which uses the decoder portion of the transformer architecture to generate text, BERT, which understands context from both directions, using an encoder. Google's LaMDA and PaLM 2. Models designed for dialogue and multitasking applications. And the open-source Stable LM models. These models are characterized by their ability to understand and generate human language, NLU and NLG, and generate various types of text, such as stories, poetry, essays, and code. Google Gemini is an advanced multimodal AI model that can understand and process multiple data types, including images, audio, and video, in addition to text. 3. Generative Adversarial Networks, GANs. GANs consist of two competing models: a generator, which attempts to generate fake data, such as images, and a discriminator, which attempts to distinguish between real data and data generated by the generator. This competition aims to improve the generator's ability to produce realistic outputs that are difficult to distinguish. GANs are commonly used in photorealistic image generation, style transfer, and deepfakes. GANs face challenges such as mode collapse, where the generator fails to produce diverse outputs, and reaching Nash equilibrium, where no model can improve its performance by changing its strategy alone. A conditional generative adversarial network, CGAN, allows for control over outputs by feeding models additional information. 4. Diffusion models. These models have emerged as a powerful technique for generating high-quality images, such as Stable Diffusion. They work by gradually adding noise to the original data, forward process. Then the model learns to reverse this process, to gradually remove the noise and generate new data, reverse process. The generation process can be guided using conditional information through techniques such as label-free guidance. 5. Variational autoencoders. These are other generative models that learn compressed representations of data in a latent space. They differ from GANs in that they study probability distributions of the data, allowing new samples to be generated from this distribution. An autoencoder is generally a network that learns compressed representations of data. Training and use. Data and learning. Generative models rely on massive amounts of data for training. Unsupervised learning can be used where models detect patterns in unlabeled data. Or self-supervised learning, where supervisory signals are generated from the data itself. Contrastive learning is a common approach to self-learning. Pre-processing, before training. Text is often divided into smaller units called tokens. Through a tokenization process, an embedded is a low-dimensional vector representation of words, or units that captures their meaning and semantic relationships. E.g., Word2Vec. Training and tuning. Neural networks are trained using algorithms, such as backpropagation and optimizers, which adjust the model weights to minimize the error measured by the loss function. The learning rate is a hyperparameter that controls the size of the update steps. After initial training on large data sets, fine-tuning can be performed, which involves additional training on a smaller, more specialized data set to improve the model's performance on a particular task. Transfer learning is the general principle for reusing a pre-trained model. Prompts. When the model is used, the inference phase, it is guided by a prompt, which is the input text to define the desired task. Prompt engineering is the art of crafting effective prompts to achieve optimal output. Advanced techniques include chain of thought prompting to detail the steps of reasoning. The anchoring effect means relying heavily on initial information in the prompt. Evaluation. Metrics such as perplexity are used to assess the surprise of language models, less is better. And the FID metric, to assess the similarity of the distribution of generated and real images. Cross-validation is used to assess the model's ability to generalize to new data, capabilities and applications. Artificial intelligence has generative computing has a wide range of applications, including content creation, generating creative texts, stories, poetry, articles, code, such as GitHub Copilot, marketing texts and text summarization, media generation, generating artistic or realistic images from textual descriptions, DALL-E 2 Midjourney Stable Diffusion, generating videos, Sora, generating music, music generation, and synthesizing speech, text-to-speech, assistance and support, advanced chatbots, ChatGPT LaMDA, assisting programmers, assisting with scientific research and data analysis, customer service support, and assisting with medical diagnostics, CAD, design and innovation, generative design to explore multiple design solutions, assisting with the design of structures for 3D printing, additive manufacturing, synthetic data generation, generating synthetic data to increase the size of training data or preserve privacy, challenges and ethical considerations. Despite its immense capabilities, generative AI faces significant challenges and considerations. Accuracy and reliability. Models may hallucinate and confidently generate incorrect or misleading information, necessitating output validation and fact-checking. Bias. Models can reflect biases present in the training data, leading to unfair or discriminatory results. Copyright and intellectual property. The issue of ownership of AI-generated content raises legal challenges. Deepfakes. The ability to create highly realistic fake media raises concerns about misinformation and fraud. Transparency. And explainability. XAI. Large models are often black boxes, making their decision-making difficult to understand. Techniques such as LIME and SHAP aim to explain predictions. Privacy and data security.